Welcome to Module 3 of the No-Code Blueprint, Software Solution Components. The intent of this module is to get you thinking about the sorts of components that you'll need to consider when you design your software application. You can think of these as logical building blocks that will make up your software solution. It's also important to note that whilst many of the components are technical in nature, others are not. And it's important that you consider both these technical and non-technical components when building your application. Things like documentation are a good example because no one likes doing documentation, but it really is important. Customer onboarding and success are also very important as well, and good examples of those. But let's take a walk through the list. As I said, there's a lot here. Feel free to watch this one or two or multiple times to cover off all of the detail. So firstly, while some applications may be designed to work independently of a user, things like automated data integration, the majority of solutions will require some form of interaction with a user, and typically this will be the type of software product that you'll be designing and building. One type of interaction will be the ability for a user to input items to the software, for example, typing the contents of a tweet into Twitter. Other types of inputs are the use of a mouse or a touchscreen on a tablet or mobile phone, as well as the camera and microphone on all devices. Finally, you may need to gather inputs automatically, for example, the integration of transactions from a bank. So think about how you'll use these in a combination or individually to gather inputs from your users, especially things like, biometric validation, camera, if we think about things like Instagram, all of those sorts of things, you have various options available to yourself here. Next, outputs, and having gathered inputs from the users, done some form of processing with this, which we'll cover off a little bit later, your software will then need to be providing some form of output. And this can be done using one or more combination of options. You can display something on a screen, you can provide it in an audible output, or perhaps even some haptic output by making a mobile phone vibrate. Outputs might also include a form of automated integration. So for example, where you might be pushing something to another application, or for example, creating a tweet to then automatically post from your application, or even providing a printed report or similar. I mean, old school, right? But people still do print things. Next, then you'll need to think about your user interface, and this is where you provide a mechanism to gather user input. This is something that we all have experience in using, probably different experiences, some very good, some very bad, some mediocre. But think about how you browse Facebook, or perhaps how you transfer money or pay a bill in your banking app. A user interface, in essence, should be simple. It needs to be efficient. It needs to be laid out logically. And it needs to provide feedback and handle errors well. So for example, a user typing an email address where you might be expecting a date properly. Those are the things you need to look out for. User interface design is a discipline in itself, and we will be dedicating a whole module to this topic. So more about that, more about the user interface design later. A database is where you'll be storing most, if not all, of the data related to your application. And there are several types of databases available, such as relational databases, things like Microsoft SQL Server, MySQL. And then there are also NoSQL or document databases available, things like MongoDB, AWS, Dynamo, or even hierarchical databases like the IBM Information Management System. The choice of database and vendor will be dependent on the application you're building. But it should be noted that most no-code tools and platforms will provide their own internal database technology for you to use. So for example, Bubble and Glide all use their own internal databases, but also may allow you to connect to external databases. And these are no-code platforms like Retool, and also applications like Bubble and Glide will allow you to connect to external data sources. Generally, your database will need to be a representation of the real world where your application is working. For example, your database might contain customer details, product information, and sales transactions. Your database design will detail all of the real world items, which we call entities, how they are described, which we call attributes, and the links between them, which we call relationships. Database design is really vital to your application, and we will therefore dedicate a whole module to this later in the course. This is where I see many projects fail, where sufficient detail and attention hasn't been paid to database design. As one of the introductory sections, we spoke about how software applications generally automate processes or events. So let's take a look at some simple examples of a calendar application like Outlook, Google Calendar, Apple Calendar. The user adds an appointment and sets a reminder, which is input. The application then determines when the reminder should go off. This is the business logic. And then at the right time, it triggers an alarm. This is the output. More complex examples would contain computations, like Shopify, for example. A user would choose the product they want to buy. This is the input, how many of that item they want, and the application would then work out the subtotal, add tax, work out the grand total, and then provide some form of output. Business logic is also contained in applications. For example, look at Amazon. A user would select their delivery address, how soon they would like to receive their goods, and the software then determines the best delivery option and cost. Applications can also contain workflows, and this is where something goes through a logical sequence of steps. An example of this would be the tracking of a parcel delivery. As an event takes place, an update is made in the software application, allowing users to track their delivery. So this is done automatically, but the user viewing that delivery progress is an output. Next, you'll want to think about manual procedures. So where we've previously spoken about software automating some form of process, however, as a no-code builder, you'll also need to consider any manual processes that would need to take place. For example, an administrator adding a new user to the platform, a user requesting a download of their data, as is done with Twitter or Facebook, or a user creating a database snapshot in Airtable. Those are all manual processes and something you can't necessarily automate. You'll need to think about what these activities will be, who will perform them, and when they should be performed, how they should be performed, and where they will be performed. Next, you need to start thinking about the controls that your application will need. These will be things like input controls to validate input from users, for example, making sure that a user enters a date where a date is expected. Next are processing controls that may need to be in place to ensure consistency. An example of this is accounting software that will ensure that any debit a user enters would have an equal or matching credit to make sure that that journal is balanced. Output controls generally take the form of totals, and this is to ensure that data has been captured or processed correctly. So almost think about you filling out like a deposit slip at a bank where you're adding up the notes and checks and it's giving you a total. Or for example, where you're checking out on Amazon, you've got 3 or 4 line items and it's calculating what the order of that order is, the total of that order is with shipping. This is a good example of an output control. And then finally, procedural controls like passwords will need to be used. And this would cover events such as signing in or completing some administrative task on the software application. Which leads quite nicely onto security. So the previous section we spoke about controls like passwords. Unless you are only building an application for a single user, you'll need to think about your security model. For example, if you're building a SaaS application, that's software as a service, in the business to consumer space, you would obviously ensure that users wouldn't have access to each other's data. However, you may want some kind of family account, and within this family account, you would have varying levels of security. Many no-code platforms do make it easy to implement security models. So this will help you when you decide what that security model is going to look like. If you were building a business-to-business type application, you would want some users to see their organization's data, but not that of other organizations. And then within organization, there would also be varying levels of access. The majority of the software today is on the cloud. Does this mean that it's immune to data loss? Absolutely not. So your application will need to provide some form of disaster recovery. For example, if a user accidentally deletes 100 of their customer records, what options exist to get that data back? Finally, you may also need to put in place audit trails. Those are the trails that record events and activities in your application. And there are a variety of use cases for this, such as forensics, troubleshooting, or compliance. So think about money going missing from your bank account. The bank will have an audit trail or a set of forensic activities in place to find out what happened to that money. Documentation always seems to be our last and least favorite item to complete. However, as I mentioned earlier, it is very important, and we can break down documentation into three key types. There is system documentation, and this details how an application is designed and constructed. This might include software architectures, process flows, and database diagrams. This documentation is especially helpful to maintain and enhance the software you build, especially if these activities take place at a later stage, because we all forget what we've done, even if it is only a few months later. Or some of these future activities might be completed by someone other than the person who created the software. Very pertinent if you're developing a product as a team, so that every member of the team knows what someone else has done when it came to the build and design of that software. Next, you've got operations documentation, and this is primarily meant to help an administrator operate and maintain the software application. So potentially, how to assign software licenses or add users or install something to help a user get onboarded. And then finally, user documentation is built to help the end users learn to use the software. And that really is the functional aspects of the software. So how do you do something? What should you expect? FAQs, what to do when you get stuck. An often unthought of activity is conversion, and this is really around the applications providing an ability to upgrade from either an earlier version or from a competitor's product. This is a very complex thing to create, but often it's a big draw card when you create a product or a software solution to say, we can bring your data across. So it could be, providing the ability to import data from spreadsheets, text files, or databases, or if you were really advanced, pointing towards the old application or the competitor's application, and then converting all of that data automatically. Again, probably something you won't be doing in your first project, but something important to think about for futures. The type of product you build will determine the training approach that you'll need to take. So if you're building an application to be used in the corporate world, then you might be training people one-on-one or face-to-face in a classroom or on an online session. And this is obviously not practical when you build a business-to-consumer application, and you'll want to need to use media such as online manuals and videos in a similar way to you consuming this content and learning about no-code software development. You would want to do the same to help people learn about your product that you're offering them. To understand what you'll need to provide, you should perform a learning needs analysis, and that really is to determine what it is that your users will need to learn. You can then base your approach and content on this learning needs analysis. And finally, once the software is successfully developed, the job doesn't stop there. As I said, many organizations roll out new software and fail to properly address the process, role, and job changes, even the organizational changes that will need to happen alongside the rollout of the new software. A business change methodology is normally employed to address the people and process aspects of rolling out a new software, and this ensures that the software has a high chance of successful adoption. In a business to consumer type of scenario, you'll need to think about your support model for your users and encourage them to use and get the most value out of your software that they are paying for. Right, so we've covered off quite a lot in this module. Take a break, and I look forward to seeing you in the next module.